Hi, Stats. This is, I'm going over a little bit of page 117 and 118, which is due on Wednesday, the 13th of September. So the first question talks about inches of rain in Des Moines. And so what I did is I went ahead and plugged this into Desmos already. So if I want to do the box plot of L, and I hit the plus. Make sure you have the button that says exclude outliers. So this clearly shows we have outliers. Those three dots off to the right are definitely outliers. But then what we need to do, some other things, is if you type in stats of L, notice it gives us the min, Q1, median, Q3, and the max. Okay, so what we can do, just mark this down. We have Q1, which is 19, Q3, which is 27. Okay. So we have to figure out what is our absolute boundary for a min or max. So if I want to figure out if I have a minimum outlier, it's going to be Q1 minus 1.5 times the IQR. Okay. And then the max outlier is going to be Q3 plus 1.5 times the IQR. So being that I know that my Q1 is 19 and my Q3 is 27, if I subtract those from each other, so 27 minus 19, it's going to be 8. So this is my IQR. Okay. So if I run through and I find my minimum Q1 we said was 19, so I'm going to go 19 minus 15, or 1.5 times 8. If I do that on a calculator off here to the side, so I'm going to go 19 minus 1.5 times the IQR, which is 8. So that means my minimum outlier is going to be 7. So if you looked at your Q1 data, Q1 happened to be 19, so 19 is not an outlier. But let's figure out if the other number is. So then I'm going to take Q3. So I'm going to go 27 plus 1.5 times the IQR, which is 8. Now it's going to tell us our upper outlier, so plus 1.5 times 8. So this upper outlier is 39. So that actually tells us that to find outliers, anything beyond 39 is going to be an outlier. That would be one of those dots that would show up. Okay, and then if I move down and then you construct the box plot, well, we have that on the Desmos. Okay, so then on the next one down on the bottom, I have a min at 6, Q1 at 26, median at 30, Q3 at 34, and my max is 44. Okay, so here's my box and whiskers on this situation. So this is Q1, this is Q3. Now we want to see if either of these is an outlier. So I'm going to do Q1 minus 1.5 times the IQR to see if the 6 is an outlier, or I'm going to go Q3 plus 1.5 times the IQR. So the IQR is going to be 34 minus 26. It happens to be 8 again. That's coincidental. So I'm going to take 26 minus 1.5 times 8. If I do that on a calculator, I get 26 minus 1.5 times 8, which is 14. That means this is an outlier. Okay, and then if I check the other one, if I go Q3, so 34 plus 1.5 times 8, so I get to 46. Okay, so this is not an outlier. That's fine. So are there any outliers in the data set? Yes, the number 6 is an outlier. So we can't construct from our 5-number summary. It's impossible to actually have this drawn because this tail should be somewhere over here. But I don't know exactly where our min would be, this being that's an outlier. So that's one thing to be looking at. as far as 118, don't worry too much about that for right now. But let's go in and take a look at our lesson, which is on, let's see, it's page 111. So I'm on page 24 now in the book. Okay, so you have statisticians and researchers often split quantitative data another way into nominal and ordinal and in the scale. Or I spelled ordinal wrong. ORDINAL. Okay, so nominal, these are categories. So they could be like your favorite TV show. They could be things that you can't calculate. So you can't calculate, so you can't find the mean, and you can't find the standard deviation with nominal data. Ordinal data is like your ACT scores or your SAT scores or your AP scores, anything like that. That would be ordinal data. So when you look at ordinal data, it says label, outcome sequence that have no measurement of value beyond that. Your ACT score, a student who obtains a 23 on the ACT knows that they performed higher than the student who scored a 20, but the score offers no specific measurement about how the student performed. Ordinal level variables include the following: ACT and SAT, military rank, the position of finishing a race, and your IQ. So IQ, race, things like that, or race like running a race, so first, second, third place, things like that. And then you have ordinal level data possesses no scale units. The measurements are merely placed in observation in sequence, perhaps the highest, lowest, or lowest to highest. How close is the runner in the 22nd position to this runner? Those kinds of questions, variables, higher level. And then you have something called the Likert scale. Okay, and so Likert scale. And the Likert scale is like a 1 to 5 rating. You might also see Likert scales like in a doctor's office. They might have something like this. And that's also be a Likert scale. So they are quantitative and precise. They often measured with instruments, well-defined units of measure. If you're measuring the variable of temperature, the units may be in Fahrenheit. Okay, so the Likert scales would also fall into that. In summary, many statisticians require a level of precision and instrument of data. The mean, standard deviation are only appropriate for scale level variables, so it's going to work here. Okay, and I'll also work on ordinal. Okay, that's what's going to go. So your assignment for next time is going to be page 111, which looks to be page 119, 120. Okay, have a nice day.